We are talking about visible light, which is a region of the electromagnetic spectrum. Visible light consists of different colors, inclusive of red, orange, yellow, green, cyan, blue, and violet. As seen on the screen, you're going to see the different colors which are found in the visible region of the spectrum and their wavelengths. While you are not required to know the specific wavelengths for each color of light, you are to take note that visible light, that is red light, has a wavelength of up to 700 nanometers, and violet light has a wavelength which may start at around 380 nanometers. Let's look at what this means. And I'm looking at the statement below, which says a small or short wavelength is equal to a large or high frequency, and this is equal to high energy. Where we have a short wavelength, which is violet light with a wavelength of 380 nanometers. This makes violet light a higher energy than red light. Red light has a wavelength of up to 740 nanometers. It has a large or long wavelength, which means it has a shorter frequency, and therefore it is lower energy. So violet light is of a higher energy compared to red light, which is of a lower energy. This means if given an electromagnetic spectrum and you are asked to indicate on this spectrum where red light or violet light occurs, that is it closer to a shorter wavelength or closer to a longer wavelength, you are expected to know where it occurs. Let's look at this diagram. There's additional info on this diagram with regards to the electromagnetic spectrum. What are the different regions in the electromagnetic spectrum? Does that region refer to a short or long wavelength, a low or high energy, or a low or high frequency? What we are focusing on is the visible light, which is at the bottom of the diagram. We see that for visible light, violet starts at 380 nanometers, and this means it is of a shorter wavelength, higher energy, higher frequency. A good trick to remember is that violet is next to the ultraviolet region of the spectrum, and therefore this means it should be of a higher energy as compared to red light, which is of a lower energy, that is a longer wavelength, it's lower energy, and it should be of a lower frequency, and red light is closer to the infrared region.